It might be a little loud in here. I am, again, in the Boyd classroom. Hello. And there's a library class going on next door. I think they should leave in the next 10 minutes or so. So I'm not sure if you can hear me that well, so I'll try to talk loud. And the few things that I have, I'll try to focus this a little bit. No? Maybe? Oh, is that better? Yeah. You can use a calculator, remember. And I am in our yellow packet on page 6. And you definitely want to have a pencil, but I noticed that pencil doesn't show up as well on this camera, so I'm just going to use these erasable pens right here. All right, let's get started. By the way, this is dedicated to all you kiddos out there stricken with the flu. I sure hope you feel better soon. All right, so we did these as a class, this page right here. We did this as a class on Monday, I believe. So, let's read it. It reads, if rainforests are left intact and renewable, sustainable resources such as nuts, fruits, and oil-producing medicinal plants are harvested. So basically, if we don't touch the rainforest, statistics show that the land would be worth this much money per acre, $2,400 per acre. But instead, if we cut down the trees and we harvest the timber from the land, it would only be worth 16 2/3% of that. So the point is to say that if we leave the rainforest alone, it's worth more. But anyway, so we'll read it again. If rainforests are left intact and renewable and sustainable resources such as nuts, fruits, and oil-producing medicinal plants are harvested, statistics show the land would be worth about $2,400 per acre. If the timber is harvested from the land, it is worth only 16 2/3% as much per acre. How much is the rainforest land worth per acre if the timber is harvested? So we have enough data here, right? You know, whenever there's a percent, I'm just going to work over here for a second. Whenever there's a percent, 16 2/3, you know that is automatically over 100. It's not a good pen. So you know that you have 16 2/3 over 100 equals, and then 2,400, that's the total. So that would go down here, 2,400. So we're looking for X. You could cross multiply and divide, right? You could take 16 2/3 times 2,400 and then divide that by 100. The issue though is that we're working with this 2/3, and it's kind of a pain to punch into a calculator, right? Because we know that 2/3 is 0.6 forever. 0.6666666666666. So we are going to try to find an alternate way to solve for X, for number 4. So, I'm going to write this out in kind of step form, just to kind of help the both of us. So, again, our goal, though, is to turn this 16 2/3% into a fraction. That's a percent right now. So, our first step, I'll put 1 right here. Our first step is to think of what is, let's see, 16 2/3% is, okay. We need to work with a number that we are more familiar with. We need to find one of those benchmark fractions, right? We know that if we take 16 2/3 times 2, we know that equals 33 1/3%, right? And we know that 33 1/3% is a benchmark fraction. Remember, benchmark fractions are the fractions we just automatically know, right? You know 1/2 is 50%. You know that 75% is 3/4. You should know that 1/3 is 0.33333. You should know that 33 1/3 is 0.3333. If you need a refresher, remember 33 1/3%, I'll just put it up here, is really 33.33333, on and on percent. You move the decimal, boom, boom, you get 0.33333, which is 1/3. So all we did is we just took 16 2/3, which is something that's tough to work with, and we just changed that over to a benchmark fraction, one that we know what it means. So step 2 is just that we know that 33 and 1/3% is, or as a fraction, is 1/3. Ah, that's so much easier to work with. Just the fraction 1/3 is so much easier to work with than 16 and 2/3%. We can work with thirds, all right. Now, since we doubled the original number to this, now we have to half it. So now we have to half, I'm going to write that down. So since we doubled it, we now have to have, oh man, I'm probably just confusing you, huh? We now have to half it. And what that means is that we have to take 1/3, divide it in half, and we get, anybody? 1/6? Good job. 1/6. Yay! 1/6 is so much easier to work with, right? So now all we have to do is find, oh, I'm running out of room. Now not all we have to do is step 4, is what is 1/6 of our total? 2,400. Well, that's easy peasy. Just divide this by 6. Which equals, let's put that in our calculator. On. Oh, error. I hope you can read this. 2,400 divided by 6, because we're talking about 6, equals, oh, I messed up. Let's do that again. 2,400 divided by 6 equals 400. Boom. That's our answer right there. That's probably confusing because I can't really see my face or any of my facial gestures or anything like that. So one more time, I will explain that. We know that 16 and 2/3 is what we have now, or not what we have now. We know that's how much the timber would be worth. First, the 100%, $2,400 if we left the forest alone. So we're trying to figure out this. How much money would that be worth per acre, right? Because that's going to be $1. So what is 16 and 2/3%? You could cross multiply and divide, but you're going to have to deal with the 2/3 right there, which is tough to work with. So we just changed 16 and 2/3 to 33 and 1/3% by multiplying that percent times 2. We know that 33 and 1/3% as a fraction is 1/3. That's just a benchmark fraction. That's just something we have to know. Since we doubled this original number, we have to now half it because we have to keep everything balanced. So we took this 1/3 and halved it. 1/3 divided by 2 is 1/6. Now we just need to figure out what 1/6 is of this original 2,400. And since we're taking it by sixths, we just take this number divided by 6 and we get 400. Give you a second to take that in case you need a moment. Now we're going to do our model. So, this is always 0, 0. This is 100%, right? We know that 100% is 2,400. It tells us that in the problem. So 2,400. But since we're working with thirds, we're not going to count by tens. We're not going to go 10, 20, 30, 40, 50, 60, 70. We're not going to do that. Instead, we're just going to do it by thirds. So it already gives us 16 and 2/3%. 16 and 2/3%. The next section would be 33 and 1/3%. Doubling that would be, or adding these two together, would be 66 and 2/3%. All we did is just split this in, well, we went by thirds, but broke it up into 4 sections. So this is now x equals 400. Boom. This is going to be 800. This is going to be 1,600. And there's our model. The reason why that one is so tough is because we're working with thirds. But don't fret on your final exam, or you know your pre-test that you took, and you're going to take the same post-test later. I'm pretty certain there are no thirds involved. If there are, we'll spend a lot more time on that together. All right, let's look at question number 5. Question number 5. And this time we'll do the opposite. This time we'll start with a number line, and then we'll do our equation. So we'll start with a number line this time. This one reads, a 4 square mile patch of rainforest contains as many as 150 different species of butterflies. So we have a 4 square mile patch of rainforest, and there are 150 different species of butterflies. All right? This is 37.5 of the number of species of birds in the same area. How many species of birds are there? Ooh. One more time. A 4 square mile patch of rainforest contains as many as 150 different species of butterflies. This is, so we know 150 is 37.5%. So if we were going to sneak down here and do our equation, we know 150 equals 37.5%, right? We know we know a percent automatically has to go over 100%. So we know we're looking for this. So anyway, this 150 is 37.5% of the number of species of birds in the same area. How many species of birds are there? So we're looking for 100%. We're looking for that 100% x. So let's put our 0 up here. We'll put our 100% up here, and that is x. That's what we're looking for. This is 0, right? 0%. We know what 37.5 is. Let's see. I'm going to guess that 50 is like right here. So 37.5 would be here-ish. That's where I'm putting mine. 37.5% is 150. But we're trying to get all the way over here. So we're dealing with this annoying 0.5%, right? So let's take 37.5. If you were here in class, I would say, how would you take 37.5% and make it a whole percent? And you would say, you would double it. So that's what we're going to do. We're going to double it. 37.5 times 2 equals 75. So let's go to the 75 mark. 75%. If doubling this gives you 75, then we should be able to double this to get what that percent is. So doubling this would be 300. Now that we have 75% is 300, now we can get 25%, right? 25%. And to go from 75 to 25%, we divide by 3, right? 75% divided by 3 is 25. So we just take 300 divided by 3 to get what this would be, which is 100. And now we can get x, because 25 goes into 100 4 times. And so that would be 25 times 4 is 100. So 100 times 4 is 400. So x equals 400. So that's how we would use the number line. You don't have to fill in the 50. If you want to be an overachiever, go for it. Right? That would be 200. Right? 2 of these? Yeah. 200. Is that right? 150, 2 of these, 100, 200, adding it up. Yeah, that's right. Awesome. I'm going to erase this so I can put it up higher. So now let's show our equation, which we know, again, it says 150 is 37.5%. We know a percent is over 100 no matter what, so we're looking for this x. So we can just cross multiply and divide. So let's clear this off. I always hit clear 10 times, just in case. So I'm going to take 150 times 100, because those are the two numbers that are diagonal from each other. So 150 times 100 equals 1,500. Now I'm going to divide it by the remaining number. Divide it by 37.5, and I hit equals. It should say 400. 400. So we know we set this up correctly. But we have to show how that works. Remember, you just can't throw it in the calculator. You have to show how this works. So to show how cross multiplication works, we need to multiply each side by the opposite side's denominator. Right? Yeah. So on this side, we're going to multiply this by x, because x is over here. And on this side, we're going to multiply it by 100, because 100 is over here. Right? So let's solve that. 100 times 150, 1500, over 100 times x is 100x, equals 37.5 times x is 37.5x, over 100 times x is 100x. And now that we have the same denominators, they can go away. Boop, 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 boop. And we are left with what it says right here, 1500 equals 37.5. Equals 37.5. Oh, x. Sorry, x. We need to get this x alone. If you remember from last year when we did algebra, to get x alone, you need to do the opposite operation of what is currently showing. So this is showing 37.5 times x. So the opposite of multiplication is division. So you divide each side by 37.5 to get it to go away. So multiply this by 37.5, multiply this by 37.5, and we better get 400. Let's see, 1500 divided by 37.5 equals, what did I do wrong? I did something wrong. 1500 divided by 37.5 equals, what is happening? Let's see. I messed up something. 1, 2, 3. Oh my goodness, I left off a 0. That's really important. Did you catch that I did that before I did? So 100 times 150 is 15,000. Sorry about that. 15,000. So 15,000 divided by 37.5 equals 400. There we go. I was nervous. So that is 400 equals x. Awesome. Well, I'm going to go because that was like 20 minutes almost of a video just to explain these two for you. If you have any questions about that, let me know. Bye.